2026 is the year of tool changer 3D printers. A lot of them have been announced, some of them are out already, and today we're here to check out the first commercial one that brings this to under $1,000. Yep, you're right thinking I'm talking about the Snapmaker U1. After their super successful Kickstarter campaign, they brought this concept to production, and a lot of people, me included, are very excited to check it out. The biggest selling points of a tool changer, U1 included, is the dramatic reduce in waste and time between changing colors or materials. First things first, let's get it out of the box, and then we can talk about it more in detail. Standard experience so far, big cubic box. There is a QR code here on the front, which is nice. It takes you to the unboxing guide. Everything is wrapped in foil, which is good, it's gonna keep moisture out. And the quick start guide is glued to the front, along with some safety guidelines. Next, there are some foam pieces we need to remove. And then you lift the whole printer by the plastic bag. Whew. Doing this would have been easier with two people. Now we can remove the foil and the plenty of packaging material. And finally, we have the printer out of the original packaging. There's still some tape here I need to remove, and this cardboard piece on top, so let's go ahead and do that. After the cardboard on top is removed, there is a big box here. There's some foam protecting the tool head, and then some more tape that we need to remove. And all along the sides, the bottom, the other side. With the door free, we can remove the inside box now, which is also taped in place. Now this box comes out. We have a bag of desiccant. And now we need to remove a bunch of retaining screws that hold the bed in place. So let's check out the accessories boxes, see if they provided any tools for us to do that. And in box number one, we have another box. So it looks like here we have the purge bin, the assist modules, and the 4 spool holders. So we're gonna set this aside for now. This is not the box I'm looking for. And this was the box that I was actually looking for, containing tools. So let's get one of these Allen keys. The screws that you need to remove are actually marked in red, so it's gonna be easy to see. And first we remove the front protecting piece, and then we can start work on the other ones. These are in a bit of an awkward place, but with the correct Allen key provided in the package, you can still get to them without issues. And now everything should be free. There's a bit of tape left here on the build plate, which we're gonna remove after we power on the printer. And we also have some filaments included. Very nice. The power cord is in the filament box, so we're gonna take that out. Now is as good as time as any to install the waste chute, and then we can continue with the filament feeding modules, where you plug in a small cable and then push and slide them. Same thing on the other side. We take the module, and again we take the small ribbon cable. Pay attention to the connector orientation, clip it in, and then just align it and push forward. Next step would be to attach each filament holder, and this just press in. You need to pay attention to the orientation of this when installing it. There's a slot for these 2 straight cuts. Right here you can see the vertical splits. So you align this like here, press it in, and there we go. And also same thing for number 2. Now it's time for the PTFE tubes, and we need to respect the order. So the top one here is marked 1. So we just push it in, and we connect it to the underside of this one, which you'll see later on top is marked 1. And continue with the second one, and the same thing. And on the other side, again, 3 and 4. Now we get to the point of attaching the tool heads, and we're going to start with the right side. Just slide them in and push them to the right. They magnetically hold in place. And the last one, the one on the left, has this specific label that we're only supposed to remove when we're instructed to do so. So I'm going to leave this aside and continue with the installation. Next up, we take the bigger PTFE tubes and we connect each of them to the back and to the tool heads, and then the provided connection cables. There's also some included clips to help with cable management, make it all look nice and tidy. Also prepared the extra tool head for the final installation. I'm gonna set that one aside. And in the instructions, they tell us to loosen these two screws, manually cycle the print head around twice, and then retighten these screws. Then we're supposed to install these pieces that go right here and guide the PTFE tubes in place, and also hold the USB connection cable to the tool head. And then with the included M2.5 screws, we secure them to the printer. And then we also have a bag of included ST 2.6x10 screws, which are going to be used to secure the USB cables to each tool head. And now it's about time we power it on. We remove the last peel, which is on the display. Now you got to choose our language, region. I'm going to connect to Wi-Fi, and now the printer is going to perform the calibration. So after the calibration is done, we can actually go ahead and load up some filament. Starting with the first spool, we're going to use the included filament from Snapmaker, which is Snap Speed PLA, and we're just going to insert the black one into the first slot, corresponding with the roll, and it automatically loads it for the first tool head. Then let's do yellow for the second spool and second tool head. And continue on with red for the third one. And finally, white for the fourth one. And now, as you can see, the filaments are all loaded into the big PTFE tubes. Because the spools have the RFID tags from Snapmaker, and there's an RFID reader right behind the spool, the printer actually read which color and type of filament each of the loaded rolls was, and it already populated them on the screen, so you can just go ahead and hit next. We don't need to configure anything else. And now it's prompting us to print our first thing. So let's go ahead and do that. The only file available here is this dragon, and this handy little screen tells us how much of each filament this print is going to take. Also here, if you want, we can switch around some of the colors. So if you want, we can do this in white and this in yellow, or switch them back around. As always, with any brand new 3D printer, I suggest you go ahead and wash the build plate with dish soap, just to remove all the oils and all the dust that would be there from shipping, to give your printer the best chance of producing a nice quality print that's gonna stick to the build plate. This is super easy, you don't need any specific detergent, just use whatever you have available and a sponge, clean it thoroughly, then wash it with water and dry it off with some lint-free cloth. Here we can enable dynamic flow calibration, which for a first print I suggest you do, and also time-lapse so you have a nice video of it afterwards. And then it's as simple as just hitting print. The printer now is going to start heating up the bed. The tool head is homing, sensorless homing of course. So right now the printer is doing the initial purging for each tool head, and after it's going to do its left and right movement, you'll see all the purge landing in this chute that was already provided with the U1. Very neat and handy, you don't need to print another poop chute. While the U1 is doing its thing and printing this cute dragon, I wanted to share with you something that I don't really like on the Snapmaker U1, just from a perspective of a YouTuber, but maybe also as a regular user. The way they designed this front panel you can't really get in and see what's actually been printing. You can't really see the nozzle. So you really have to rely on the auto bed leveling and the AI detection in case something goes wrong, because you can't really see what's been currently printing on the current layer. That being said, if you look really closely, you can actually see one of the Z lead screws going up and down to compensate for bed mesh leveling, which clearly means that it's working, and it's working good. So that's a bonus. Another advantage of these tool changers is after you load all your filaments, the only waste you're gonna have during a print is this purge tower, which is necessary with any kind of printer to build up a consistent pressure in the nozzle. And as you just saw, the time to change from one nozzle to the next and start printing on the purge tower is extremely small. I'll put an overlay on the screen for you just to see exactly how long it is.
Of course, you can also export time-lapses from the 3D printer, and this gives us a look into the quality of the camera and what kind of time-lapses you can expect. These are all 1080p footage. And after successfully printing the initial Dragon that came preloaded, I decided to give the U1 an actual challenge, a big model for almost a day and a half, featuring 3 colors and more than 900 tool changes, which is gonna take up in the end 327 grams of filament. Let's also compare this to a regular multiplexer printer. As you can see, the time increased dramatically to 2 days and 3 hours, basically doubling it. And also, the amount of filament used jumped up significantly to 840 grams, half of that being just the filament that was flashed, to an additional 73 grams of tower. I have to admit, this was scary in the beginning, as not too long ago, sending such a long print to a basically brand new, untested machine was a sure way for disaster. But I managed to monitor the U1 remotely from the phone app, and it managed to print the stitch without any issues, which to me was very impressive, again, for a brand new machine.
So after the successful initial print that came preloaded on the printer, I decided to throw it right in the deep end and do a 36-hour print with more than 900 tool changes, which resulted into this cute Stitch figurine. And after all those changes, the only waste that we actually have is the prime tower, which is needed for any printer the moment it changes color or filament, regardless if it's a tool changer or a multiplexer system. Very, very impressive. Their claims of 5 times less waste, they're coming actually true. And now let's take a quick look at the results from the initial print and from my huge multicolor print. The pre-sliced file that came on the U1 was perfectly optimized for the printer and took very little time compared to if I would have sliced it on a multiplexer system like a Bamboo, Prusa, Anycubic, Reality, any of the other non-tool head changing printers. As far as the details, there is no color bleed, the scales and the tail look very good, and this red and yellow combination does a really good job of showing all the details and all the eventual imperfections. But of course, this being the original file sliced by Snapmaker, it's gonna come out perfect. Again, the only waste that we had was this prime tower, which, although a bit hefty, if we would have to compare this print on a multiplexer system, it would take far, far longer and have way more waste or poop compared to the U1. So this is the area where the U1 actually shines compared to everything else that's on the market without a tool head changer. The time, speed, and the savings in material waste that you're gonna get. Next up, the stitch model that I actually sliced. And again, apart from the supports, which you're gonna get on any printer, regardless of tool head changer or not, the only waste we had here is the prime tower, which, as the name implies, is what's being used to regulate the pressure in the nozzle after a color change before it starts actually printing. And as I said, this is needed for any printer, regardless if it has a tool changer or not. You need a constant pressure in the nozzle to achieve good quality results. As you probably heard from the prime tower detaching, the build plate adhesion was super good. Let's remove the model now. And as you can see, it's stuck on here really well. But it comes out super easy after it cooled down. I'm gonna remove the supports now, and then we're gonna get some B-roll to see the details on the actual model. As you can see, the surface quality is extremely nice and clean. This was printed at 0.2 layer height, and even at that height, it's perfectly crisp and nice. There are no defects in the surface, and this knitted surface gives it a nice texture, breaking up any layer lines that would become apparent. Of course, the transition from black to white doesn't have any color bleed, because this is a tool head changer. It had separate filaments for each color. There's no need for one bleeding into the other. The only defects that are actually visible are here around the chin area, where because of the nature of FDM printing, this was a very steep overhang, as you can see, and you're always going to have surface defects in these kind of areas. But on the other side, anywhere supports touched, there's no blemishes, no rough surfaces, and I'm very happy with this print. Now, let's load up some ABS and do a bunch of small little parts to see how the U1 deals with that.
In this case, since the filament was not from Snapmaker, I had to manually select the type and the color for what I already loaded up. And here you can see the parts that I need to print. There's a few brackets, a few L pieces, and those cylindrical parts that are going to take one screw. We also have a bit of infill here, gyroid. And we can also just send the print to the printer without actually starting it, so we can manually start it later from the printer's interface. We just need to rename it, select the printer from the drop-down, and then click upload.
So let's start this ABS print. And in the meantime, we can talk more about the specs of the U1. As you could probably tell from the comparison in the slicer earlier, it's very fast when it comes to multicolor or multi-material prints compared to standard multiplexer systems. Again, Snapmaker claims up to 5 times more speed and 5 times less waste when compared to a multicolor print using a standard multiplexer, and I tend to believe them depending on the number of color changes per layer and depending on how many colors you have in a print. It may actually go up to 5 times less waste and 5 times faster. Another point that I really want to drive home is the reliability. Given that its first real print was one with more than 900 tool changes, and it handled that without any issues, tells me that this is going to be a reliable machine in the long run, and maybe we'll do a test a few months later to see how it's going. Back to the specs, the build volume is 270 millimeters cubed, the hot ends go up to 300C each, and the bed goes up to 100C. Considering it's an open machine, it doesn't have an enclosure, I don't really see the point of the bed going much higher than that, because you won't be able to print engineering materials anyway. They're gonna warp and produce some bad results, so you should stick with the standard PLA, PETG, maybe some small ABS or ASA parts, just like I'm doing now. But we're gonna test bigger ASA parts later, just so you get an idea of how it deals with that. Snapmaker also offers the additional top hat for it, where it encloses the machine so you can trap a bit more of the heat inside for ABS prints, but it doesn't really have an included chamber heater, apart from the heated bed of course. So you can clearly see the machine was not designed for engineering materials, but more for multicolor or basic multi-material combinations like PLA with PETG supports or vice versa, or combining PLA and TPU parts to make some functional parts, or again TPU and PETG. When you get such big time savings in your prints, up to 3 or 4 times faster prints, that means 2 things. A, less electricity consumed, so your costs go down. And B, your machine is not going to be tied up for so long, so you're going to be able to either print more or print more efficient. As you saw already, the time to swap tool heads from one to the next is extremely fast, and it's under 5 seconds for the swap itself. And from color to color or material to material change within a print, again, it's extremely fast. You saw it in the beginning. As you saw already, the printer is built on a Core XY motion system, which gives it its speed. The linear bearings on the X-axis are actually carbon fiber rods, which make the moving assembly much lighter compared to steel rods. And it also has a camera for AI detection and spaghetti monitoring. And you can use it for live monitoring while remote, but the frame rate of the camera is really low, something around 1 frame every second. So it's good if you want to check how the print is doing and if there's any failures, but you won't get live real-time monitoring out of it. Another quality of life improvement, as you saw when I was loading the filaments the first time, are the auto loaders on each side. Instead of you having to manually feed the filament all the way up to the tool head, you just give it to the auto loader and it does the rest, pushing it all the way back. There's also RFID tag readers on each side of the machine. So if you're going to use filaments from Snapmaker, the printer will automatically recognize those and adjust the settings, but you're not locked into that ecosystem. You can use any filaments you want. The U1 runs on Clipper-based firmware, which is great. And as you saw, it also uses Snapmaker Orca, their own version of Orca Slicer, which is going to give you all the options the standard Orca Slicer has, with some optimizations made specifically for the U1. As with any electronic device, the moment you get it, I suggest you update the firmware, because especially if it's a new product, day zero patches are going to be pretty constant, and you're going to get some good optimizations if you actually update the firmware, so I really suggest you do that. One thing that could be improved in terms of usability is how fast a print actually starts from the moment you hit print. While I've been talking to you here, the machine is still doing the initial calibrations and right now it's leveling the bed, so all this sequence could be shortened for a much faster print-to-print time. I'm going to let the U1 finish my ABS parts, see how they come out, and then we move on to the ASA testing. Unfortunately, here's where we run into our first failure. Because ABS has a tendency to actually warp upwards, as you can see on some of these parts here, when you don't have an enclosure to trap the heat and protect it from drafts of cold air, some of these parts detached and we have our first failure. At least the AI detection worked properly and it's saying spaghetti defect detected, and we have the option to either continue, which we won't do, or cancel this outright. So let me clean this up and I'm gonna start the ASA part. Let's see if that holds up better. And now, to give the U1 the best chance it has at success with my little ABS parts, we're gonna apply some glue stick to the bed in the area where we're gonna print to make sure the parts don't lift and have a better chance of sticking. Another trick you can use with machines like this that are not fully enclosed is you can start preheating the bed for 10 minutes before you actually start the print, so it gets some chance to get some radiating heat inside the printer. The SA part finished and we can talk about it now. Unfortunately, due to the design of the U1 with the open chassis and without having a chamber heater, parts like this out of high temp material, even though I turned off the fans completely, they still had the tendency to warp and in the end almost lifting from the build plate, as the ABS parts did. If we take a closer look, you can see some of the layers actually got squished when they pulled up. So there's clearly some warping going on here. My conclusion is the U1 is not really suitable for high temp material like ABS, ASA, nylon, polycarbonate and stuff like that. You're better off suited if you keep this for PLA, PETG, TPU and any other low temperature material that doesn't require an enclosed chamber. Moving on, this couldn't be a 3D printer review if we didn't of course make a benchy, but this one is a bit special. As you can see, it's a benchy in 4 colors, taking full advantage of the tool changer on the U1. If you look really close, you'll be able to see a bit of stringing. And this brings me to another one of my complaints about the U1. The filaments are actually stored outside, not in an enclosed, humidity controlled environment. So during the time of making this review, my filament got a bit moist and there we have some stringing to prove it. Other than that, the quality of the benchy is quite good, considering the amount of toolhead changes and color changes involved in here. There is no color bleeding, and if we take a small flame to it, all the strings are gonna be gone and we're left with a perfectly usable benchy. So I guess it's time for some conclusions. After spending a week with the U1 and throwing everything I had at it apart from TPU, printers like the U1 will shine exactly in this scenario. We're gonna have multiple colors in the same print, especially with multiple color changes on the same layer. where the speed of the changing tool head is going to prove its worth compared to just purging material with a normal multiplexer system. There are other scenarios where this also shines, especially when you want to print very high quality parts. You're going to use different material for support, and with a one nozzle system that means a lot of filament changes and actually risking your part deteriorating if you're going to print PLA and PETG with the same nozzle. Not the case here because they're completely separate, so you can have one nozzle for PLA as a support material, one nozzle for your PETG as the stuff you actually print with, and maybe one nozzle for TPU because you can actually combine all of these and have a very solid PETG part with some TPU inserts to make it flexible, all printed on PLA supports to have that perfect support interface. The U1 is perfect for people that are gonna do multicolor, multi-material, but nothing above PETG, TPU, anything really in the 240, 250 nozzle area and 70 degrees on the bed. It's a perfectly capable machine for that, and probably you can get away with some small ABS or ASA parts if you have the top enclosure on, but I don't. But we really have to appreciate the strong points here that the U1 brings to the table, and that is much faster color or material changes and much less waste. If we take a look at the waste bin, after printing everything on the table and more, this is everything that's in it. Considering this stitch had more than 900 tool head changes or color changes, this is extremely impressive. For the price point where it lands, the U1 doesn't really have any competition right now, so that makes it a very good value if you're into multicolor or multi-material printing. And if you think about getting one, of course there's gonna be a link down in the video description, go check it out. If you enjoyed the video, why not leave it a thumbs up, subscribe to the channel for more tech videos like this one, and I'll see you next time.